Um, Welcome everyone to this session, and myself Ramoji. I am a committee member of this PWI Bengaluru section, and yeah, everyone is fine. Um, Thank you for attending this session, and I am proud to say that we PWI Bengaluru section is the first forum to present the track work in the iconic RRTS project, and this is being headed by Akshay, and Akshay is working with L&T right now. He is a PWI professional specialized in non-ballasted tracks with experience of over 15 years in urban metro designs. His experience covers greenfield, brownfield projects from concept to commissioning. He is a graduate from IIT Roorkee and gold medalist from IIM Ahmedabad. And and you can after we start the presentation, you can type your questions in the chat box and those will be answered at the end of the session. Please mute your mics. And in this session, I wanted to announce that this is the 140th year of PWI. On this occasion, Shankar Dev, our committee member, would like to present for 2 minutes.
Thank you, Mr. Ramoji.
Yes.
So briefly, I'll just finish it in a minute. So PWI started in 1884. This is the 140th year of the Permanent Way Institution. And this year, on the occasion of the 140th year, our leadership has thought about a goal, has decided about a goal of getting 140 professionally registered engineers. So if you are a member of the Permanent Way Institution, wherever you are, and especially this is directed mainly to PWI members in India, please go ahead and see if you qualify for the qualifications of professional qualifications for Eng Tech or iEng or Say Eng. And if you do, please do apply, because let's work together and achieve the 140 number on the 140th year. In case you are not a PWI member, I would request you can probably start thinking about becoming a member and then becoming professionally registered. So thanks a lot, Ramoji. Over to you.
Yes, Akshay, you can start your presentation, please.
Ramoji, are you able to see my screen?
Yes.
Okay, great. So good afternoon, everyone, and I thank you for taking time out from your busy schedules to attend this session. And I always take such sessions with great pride because it's a forum for exchanging knowledge and gaining more by experience of others. I also thank my colleagues from PWI, especially Ramoji, who has been coordinating this with me and has been organizing this session. And in fact, who made me aware of this fraternity, and I feel fortunate to be a part of it now. The reason for me to take up this session was to share my experience in this prestigious project, and maybe it can be a good knowledge base for those who are experienced in railways, because this is first of its kind project for India, which is a semi-high speed regional rapid transit. And even for those who are not belonging to the technical railways fraternity, I have got some splendid views, so keep an eye on that. Ramoji has already introduced me, so I'll just quickly skip that, but just want to add a bit on that, I belong to L&T's Railways Business Group, stationed in Faridabad. And for those who you don't know where this is basically south of Delhi. Me and my team worked on certain design elements of this particular project. So when Ramoji said that I am heading this project, please take it with a pinch of salt, because I only did a very small part of it. And L&T, of course, was awarded this project, which is roughly 80 kilometers long, about 4 years ago, wherein we had to use a specialized slab track system from PORR, Austria. Of course, the license for this particular track type was taken by the employer, and major part of the design was also done by a dedicated design consultant engaged by the employer. But we did a few critical aspects for this project in terms of design, in terms of manufacturing, in terms of execution, for which I would like to share my experiences. Coming on to the flow of the presentation. First, I'll talk about the project overview. Then we'll go on to explain what is PORR slab track system. Then we talk about slab casting, the manufacturing of the slabs. Then some experiences from track installation, brief steps that are involved in the installation. Then most importantly, what were the challenges that we faced and what was the digital workflows that we initiated for the first time in this project. So this project was first of its kind, as you all know, which was sanctioned by the Government of India. It is a first regional rapid transit system for which the operational speed is 160 kilometers per hour and designed for 180 kilometers per hour. For L&T, the scope was basically manufacturing, supply, installation, testing, and commissioning for the entire project. Of course, the design was predominantly not in the scope. It was done by a dedicated design consultant, but L&T did a few elements of design as I briefly touch upon, and I will explain that in more detail in the upcoming slides. So the overall project cost 4 years ago, let's say, was about 30,000 crores. I don't have the exact figures now, but definitely it must have escalated. The target was that the travel time between Delhi and Meerut would be limited to 1 hour, which is a phenomenal target to start with. And the project consisted of approximately 14 kilometers of corridor in Delhi, out of which 11 kilometers was in the underground, around 25 stations, out of which 4 were in Delhi, and an estimated ridership of 8 lakh daily, which is phenomenal. Let's talk a bit more about what the PORR slab track is. So as you see on the bottom right, this image over here, this is a 3D illustration of PORR slab track system, where you have these rail seat where the fastening system will come, which will hold the rail in place. This is approximately 5-meter long element, and these are the anti-derailment or derailment containment beams that are part of the precast slab track. This element was specially designed and manufactured for the Indian context. Traditionally, the slab track PORR is a plate like this, which does not have a derailment upstand, but it does have a separation layer, some orange layer that you see below the concrete. What we do is, using a glue, we paste the separation layer, which is made of recycled rubber or even natural rubber in some cases. And what it does essentially is that in case there is a need to replace this slab element installed inside, you can just take off these concrete openings and the entire slab can be lifted. So basically this acts as a debonding layer between the precast slab and the substructure below. The reason why this slab track system was chosen for this particular project was because of the advantages that any precast slab track system will have. And that is the entire slab of 5-meter long. You have a fixed rail inclination, you have a fixed gauge, and for a considerable length of 5 meters, the track tolerances are also very controlled, very precise. Even if it is a straight section or even if it is curved section, you can install these rail seats in straight or in curves respectively, according to your geometrical parameters, so that at the end of the day, the track alignment or the rail alignment is absolutely installed in a very tight tolerance, which is very crucial for any high-speed project of this kind. The other reason was that this PORR system was very well proven in Europe and Middle East. Approximately more than 1,000 kilometers of slab track has been installed, which gives a lot of provenness, gives a lot of confidence in this type of slab track technology. And between the precast element and the in situ substructure, there's a bit of a stitching concrete that is to be put in. Now what happens is that when you lay the precast slab track, you can adjust the horizontal arrangement, vertical arrangement, any inclination that you need to provide, because all inclination is provided in the precast slab itself. So when you have to rotate the slab, you rotate the slab, and then in situ concrete you stitch below what you see here in the green part, and this gives you the super elevation that is intended. That's a quick overview about PORR slab track system. on to the manufacturing cycle of these slabs, as you saw briefly in the video before, first we have to start off with the mold preparation. So whenever the demolding has happened for the previous slab segment, there are always certain dirt and debris or the concrete remains that need to be cleaned. The mold needs to be oiled. The rebar needs to be placed. All the jewelry related to the slab track needs to be installed. For example, if there are any dowels or lifting hooks or points and so on. Then we cast the slab. The mold, as you can see here, is stationed. It's a stationary mold. It has got vibrators underneath it. And there is a small gantry unit which carries the the concrete, and it pushes the concrete in the right spot as it goes along this mold. So this completes the entire casting process. The next day, approximately 12 to 14 hours later, we demolded. We have a special demolding frame which tries to demold the slab in a synchronized manner so that no singular point is overloaded and therefore it can damage the slab. It is a very crucial element as part of the entire manufacturing process of the slab. Then next step is application of the elastic layer. So once the slab is properly demolded, it is turned upside down. Of course, it is casted upside down. It is taken aside. This is now in an upside down position. The rail seat elements you will see underneath this slab over here. On top of this, then we have specially designed tools. For example, you see this labor carrying this tool. It has got a pipe. This container has got a glue in it. And then we spray the glue on top of the concrete and then lay these separation layers as we briefly explained above. So this is essentially a deep bonding agent to decouple the precast slab element from the in situ substructure. Once this is done, then we turn the slab and check for the dimensional tolerances. Now, this is also quite an innovative way of doing it because we measure all the important tolerances using gauges, which are pre-designed, pre-defined for this kind of an application. And all the values or the dimensions are checked using laser measurement instrument. And the entire 3D image of the measured track along with its respective tolerances is captured in the system. Then we install the fastening systems on top in a pre-assembled position. So the slab which goes to site is exactly in this way, and site does not need to install the fastening. They just lay the rails, roll the rails over these fastening systems and do away with that. And of course, then we stack this, and you can see this is a phenomenally large stacking area that we have besides our manufacturing facility. This is a short video of what I explained in a bit more detail. So this image is from our very first installed track where we were learning this technology. We were trying to implement this technology. We were trying to develop new tools, and it has come out quite beautifully, I must say. Yeah. So what you saw in the video, I would like to just explain it here in a little bit. So this is a specially designed gantry that you see. I'm hovering my red laser on top of it. So this was something that was designed by L&T and implemented by L&T for the first time for this kind of a precast slab track installation. This crane that you see over here, it has got a very special equipment called a grabber. And this grabber can lift multiple slabs, 3 to 4 slabs in a single go, and try and lift it, put it on top of the viaduct. Now, in usual circumstances, this is quite helpful, but you also come across situations like this where you have the Delhi-Meerut Expressway going on top, and then you have a very serious space constraint. So there were many such challenges when we were installing the track from Saibabad to Guldhar. That was the first stretch we were working on. This was a crossover installation. Now, this photograph, I have to explain in a bit more detail because there were many challenges that were associated with it. This is a fully installed crossover that you see. Now, if you look at this crossover, you may not appreciate the kind of challenges that we face. So if you look at the installation photograph, this is our corridor on which we are working. There is a metro corridor that is passing underneath. There is also a road flyover that is passing underneath. And then there's a at-grade road, and that's an intersection. So there are 4 layers or 4 levels on which we are working here. And look at the kind of challenges from the safety point of view, from quality point of view, from logistical point of view, and lifting all these slabs, putting them in the right place, running our gantries, running our equipment, running our machinery. But in the end, when you look at the fully installed system and the right quality, you forget about all these challenges and just enjoy the moment of the train ride. So that part was for the enthusiasts. These were also some special tools and jigs that we had, designed and fabricated for installing this kind of slab track system. These are spindles where you see this L&T logo. These spindles basically allow us to horizontally and vertically adjust the slab track in the correct track tolerances so that whatever gap you see at the bottom, this can be filled in by a self-compacting concrete or the in-situ concrete or stitching concrete, which is about 10-20% of the overall concrete that is required, and approximately 80% of the concrete is done in precast. This is a better view of this grabber, which I showed you earlier. The depot construction was also a part of L&T scope. This was entirely ballasted on the outside, and within the workshop, it was completely ballasted with a typical kind of column tracks or embedded tracks that we usually have in any metro corridor. This was another interesting element of the project wherein we had to provide certain noise and vibration mitigation measures. Of course, the survey for the noise and vibration was conducted by the client, and they gave us the which type of mitigation system has to be provided. Now, just to give a brief of what noise and vibration considerations are, whenever you have a railway corridor, you have train rumbling on top of the track, and you have steel wheel in contact with steel wheel, which generates vibrations which pass through the media, which is either a structure or a soil, and it can affect adjacent buildings. So these are the vibrations that pass through. They directly vibrate the building besides it. And sometimes what happens is because of the vibrating building, the doors and the windows also start rattling, which is called a secondary air groundborne noise. And of course, you have a direct airborne noise that when the train is running because of various machinery inside the train and the aerodynamics of it, you may have certain direct noise that may be emanating from the train, from the rolling stock. Those aspects also were addressed by client, and what essentially they asked us to do was to provide an isolation layer. I'll talk about isolation layer in the next slides. to provide an isolation layer below the slab track so that all the vibrations could be decoupled. To give you a little bit feeling about what noise and vibration is and how these vibrations can perceptibly affect human annoyance level, here is a short video from our partners, Getzner, who supported us technically in this project. So this is a very simple tool that they have demonstrate how the noise and vibration really works. This is just a musical instrument which they will place on top of a hard support, which is a plastic support. And now because you are able to hear the vibrations, the volume has increased. But now when you cover the airborne noise, the volume has reduced perceptibly. Again, it has increased. Now they place it on the isolation layer or the soft layer below this instrument. So basically they're decoupling the vibrations and you can perceptibly see the volume of this instrument is reduced. Now coupling the vibration isolation with air isolation, you can hardly hear anything. And this is the basic concept of noise and vibration in the railways sector. Now this is an interesting part. I'll pause here for a minute. What this guy does is there is a pin that is now connecting the vibrating element with this structure. So in technical terms, we call it as a sound bridge, and just see that just by touching a needle, how perceptibly the volume will increase. So this is a very crucial part in the designing and installation of any mass spring system. So you have to decouple the vibrations as well as the noise, but in our scope in this project, only the vibrations decoupling was required and not the airborne noise. Now, how we did this was using basically two types of mass spring system elements. One was an elastomeric layer below the slab track, and one was using these steel elements which are embedded into the slab, and it all consistently lifts the slab up by approximately 40 millimeters. So the slab is hanging in air, and this has got a spring element. In the elastomer, the spring is provided by the microcellular structure. It's something similar to a rubber, but it's basically another chemical material altogether. Here it is a steel spring, which basically isolates the slab track vibrations emanating and going into the ground. If I show you the cross section, this is how it looks. And when you look at this cross section, I want to highlight the challenges that we've faced when designing and installing this. As you can see, there are two types of elastomer based mass spring system. One is with this orange layer strips, as we call it, and one is with a fully green surface layer. This one is called a full surface mitigation, and this one is called a strip plus filler mitigation. This provides slightly better mitigation performance compared to this, but of course this is also a little costlier, and therefore always there is a trade-off. If you need higher mitigation, you always have to shell out more money. And based on this assessment, which was done by a client, they gave us the locations where they need this type of a system and where they need this type of a system. And the challenges are that the strip layer is very close to the tunnel lining. So the dark gray line is actually the clear tunnel dia, and the single orange line is the schedule of dimensions dia. So basically the tunnel can wriggle within this gray line and the orange line. And sometimes what happens is that this orange line comes too close and sometimes even exceeds this because of course in the tunnel you can't always contain these tolerances. And therefore the challenge that comes up is, do we install the mass spring system exactly in this way or not? And for that, we had to bring in certain digitalized automated workflows, because this was a very cumbersome exercise to check these sections at every 10-20 meter interval as far as the elastomers are concerned, and even for the reinforcement. So sometimes what happened is that you cut the reinforcement for this kind of a shape, but the tunnel shifts in this way and the entire reinforcement goes waste. So in order to save that abortive work, we had also included that part in the digital workflows. So this was the cross section with all the critical elements. For example, all the corners, critical corners, the rail levels, the center of the tunnel, the actual as-built wriggle survey of the tunnel, which showed where exactly the tunnel lining was. And we could do any kind of clash detection just using a desktop analysis by making these detailed cross sections, or DCS as we call them, at every 10 to 20 meters interval. So when you get the tunnel lining is basically like this. These are the space for the banana bolts to connect the tunnel linings together. This gray part is the first stage concrete, which was given to us by the civil contractor. And the challenge always was that the level of the first stage concrete fluctuated in reality compared to the design tolerances. And also the horizontal aspects of it were very difficult to control inside. Then this yellow layer that you see, this is the elastomer based mass spring system. This is the strip plus filler element, wherein you have a slightly stiffer element, the blue one or the black one, and very soft yellow filling layer. The blue layer is a single consistent layer across the width, which we call a full surface element. And on top of this, then we do our reinforcement caging and cast our base concrete. If I go back to the section, the photo that you see with the reinforcement is in this area. So coming back, the reinforcement is quite dense. And as you can see, even a minor error in the reinforcement calculations or inside can lead to a lot of abortive work and rework, and could lead to a loss for us as an EPC contractor, where we have to be very competitive in our prices and we have to do everything first time right. Another element of this project was to do the entire project with BIM. The intention of the client is to even operate and maintain this project with BIM. So we were supposed to give them the as-built with LOD 500 level of detail, and including that, we had to tag each and every element of the slab track in the digital twin in the 3D model for the asset management systems, which eventually client will be using to maintain the project. A few highlights. We last year had a CMRS inspection, and the project was opened for public commissioning on 20th October 2023. We even touched 162 kilometers per hour, which was done for the first time in India in a regional rapid context setting. And it was cleared by CMRS without any technical observation, and the oscillation monitoring, which is basically the jerk that is observed, was above par, and it was uncomparable to any other metro that has been installed, or even for that matter, any kind of project that we have done in India. So the track parameters and the quality was so good. So that's it. That's it from my side. Ramoji, over to you. In case there are any questions, we can take it up.
Yes, Akshay. Very nice presentation, by the way.
Thank you.
Yeah. Audience can ask questions or type it in the chat box. I'm reading one by one. The first question comes from Mr. Sri Nagesh. What grade of concrete is used? Why no PSC is used in base?
Why no?
PSC, pre-stressed.
Pre-stressed. So there are, as I said earlier, this particular track system was chosen by the client for us. And incidentally, this type of design does not need any pre-stressing. But you will get certain systems in the market. For example, you can get Max Bugle or Ariana from Way Group Italy. They also have pre-stressing. Max Bugle can have a pre-stressing in a single direction. Ariana track slab can have pre-stressing in bi-directional, that is longitudinal as transverse, but that depends on system to system.
Why I ask this question is because what happens because of being a rigid structure and the vibrations will be higher, so there is every chance of cracks getting developed onto the slab over a period of time. So that's the reason why I asked this. The PSC is always advantageous when compared to reinforced concrete.
Right. It even helps us to economize on the reinforcement. But then it depends on which slab track system are we talking about. PORR, incidentally, is not using any pre-stress system. But there are other systems in the market which do use pre-stressing as well.
Thank you.
Next question is from Mr. Liben. Liben, you can ask directly.
Yeah, thanks, Ramaji, and thanks, Akshay, for the presentation. I joined a bit late, but I was wondering where you have the MSS locations and where you provided the sheets, whether the requirement of shear connectors, and if so, what were the alternative solution that you adopted for it?
Yeah, so I will go back quickly to my presentation. I'm not sure if I included the elements of shear connector there, but I believe there was a photograph. Just a second. Yeah. So when you have the first stage concrete, so that is basically in this circular shape. So you do not require any shear connectors. Hold on, do you see my screen?
Yep.
Yeah. So here, because of this circularity, you do not require any shear connectors. But when we are laying,
Sorry, I think Akshay, someone muted you as well.
is it okay now?
Yes.
Yeah, so when you have the circular tunnel lining, there you do not need any shear connectors because the restraint is provided by the circularity. But when you have the 2.4 meter wide slab track, the mass concrete on top of which the POR will have to come, POR slab will have to come, there you will have these kind of shear keys.
Okay.
Yeah.
Okay. Yeah, thanks.
Coming to the next one, we have a question from Uday Avradi. He is asking on sharp curves and horizontal transition curves, how the precast sizes are optimized.
Yeah, that's a very interesting question. That was another challenge that we faced in this project. So if I show you how the slab track is managed,
You already mentioned that in curves also you have used the straight precast slab only, right?
No, not the straight one. So basically, this is a typical slab track element which is used predominantly about 70 to 80% of the project. And the tricky aspect is to have a slab distribution list. So for every chainage, you must define that here this 5 meter slab has to come, and so on. And when the transition is starting and you have a very sharp circular curve, there are two ways of compensating that curve, either by reducing this length of the slab. So we have a possibility to manufacture these slabs with 3 rail supports, with 4, 5, 6, and 7 rail seats. So you can have anything varying from 2 meters to 5 meters. And if you have this shorter segment, you can even lay it in a versine in a relatively flatter curve. But if the curves are very sharp, then there is a possibility in the mold itself that you can shift the mold in a manner it will compensate to the curve geometry. And a particular curve geometry, we call that as arc rise of every fastening system. And that geometry can tackle a curve from a particular radius to a particular radius. So it is very important and critical that the slab distribution list is prepared and the plan of this slabs is prepared much in advance of installation. Because if you reach that particular site and then you realize that this type of slab is missing, that will throw away entire construction progress. So it is a big challenge, in fact.
The next one is viaduct, how the out of tolerance issues are addressed.
So there are a couple of ways of dealing with the out of tolerances. So one predominant way is that in case, first of all, the out of tolerance scenario is quite limited in this kind of an application. If you do the construction just right, you will get everything correct in the first go. But of course, there are always certain compromises. And even when we were learning to do this, we faced those challenges. The solution was that in this fastening system itself, you have a possibility to adjust it horizontally and vertically. So in case something goes wrong, God forbid, you still have a possibility to adjust the track within the tight tolerances.
Yeah.
Gauge widening is also through this only, through the facilities available within the slab.
So in this project, I do not recall if we did any gauge widening, but I think this has a limit of 5 mm adjustment per rail seat. So maybe for depending on the radius of curve, depending on the train maneuverability, you may require higher gauge widening also, which may not get compensated by only the fittings. Plus, the important part is as an owner of this metro line, nobody would like to use the tolerances that are there in the fastening system to provide a gauge widening effect. Ideally, the gauge widening should be provided in the molds and special molds should be fabricated. But we did not have any such requirement here because the curves were relatively flatter.
Two more questions are pending for Uday. Debonding layer, how the impact due to the shear force is compensated?
So the shear force basically is compensated by this shear key. So when you, by the way, this self-compacting concrete also has a layer of reinforcement, and this layer of reinforcement goes into this and comes out. So you have a very rigid connection between the in situ stretching concrete all around it and these box outs. So this provides, in a way, a bearing effect to the lateral forces, and the shearing effect is not that predominant in the separation layer. And by the way, the separation layer is hardly 3 mm thick. So any elastic bearing effect you can also ignore.
Next is choosing type of fastening system is flexible or not?
I think yes. I mean, you have any kind of fastening system, only this this footprint where the fastening system has to go, this can change. And there are experiences with many precast slab track systems where you can use any variety of fastening.
Did we use Waslow? Did L&T use Waslow or?
No, so this was system 300, and that system can be provided by Shrihag or Waslow. So NCRTC had procured this fastening from Shrihag. But it is very similar to Waslow 300.
Yes. Next question comes from Mr. Shankar Dev. Shankar Dev, you can ask him directly. Shankar Dev.
Sorry, am I audible? Am I audible?
Little. Okay.
Yeah. Now, probably now. Yes.
Yes. Yes.
So was LOD 500 a specific requirement of the contract, or and what softwares were used for the digital twin? Why LOD 500?
So,
because LOD 500 is generally considered very detailed digital twin.
yeah. So I can tell you, we are tagging each and every tension clamp, each and every base plate, each and every rail pad of the entire project to that level of detail you can imagine.
Yeah, I mean, for example,
And this was
so the fastening you would not, you do just a copy of you first model a fastening, and then all the components you'll just copy, but it's only the slab sizes and the dimensions that would vary, right?
yes.
So for each
Everything
and
is
every
unique. Every slab element. So suppose standard slab element is 5 meters. So that will continue, and then you will have special chorter and curved slabs also. All those details are also getting modeled in the digital twin.
So this was a specific requirement of the contract?
Yeah, this was a specific requirement of the contract.
Great, thanks.
I think I may have some. Yeah, so you can see here, this is the level of detail that we have. Each and every slab, rail element, the derailment guard, the cutouts, even the mastering system is getting modeled in this 3D element. All these slabs are individually modeled. And on top of it, the asset management system is also getting modeled and tagged. So for example, if the fastening system has got a frequency of inspection and maintenance, that is also getting tagged. if there is a failure that may happen, the client will tag it during the operational period that this fastening developed a fault and this is being tagged.
This is really detailed. This is probably the most
Very
detailed, most detailed digital twin till date in India, as of
Yeah.
now.
Yeah.
And in this context, I have a question. Like, what is the differential in separation thickness between the two slabs? You have minimum and maximum.
So this can vary, but minimum I think is about 270, 75 millimeters. This gap that you see between the two slabs, right?
Yes, yes.
Yeah, approximately 270 millimeters.
So there are no deflection issues, um, like I mean,
No, so
settle.
see, yeah, so the deflection issue will come when you have a mastering system below the slab. And for that purpose, let me show you the cross section. So yeah, so you're talking about the gaps in the dark gray section.
Yes,
Do you see my
yes,
pointer and the cross section?
yes,
And
yes.
this layer that you see, the white layer, the mass concrete is approximately 300 millimeter thick, and you have an elastic material below. So this material will bend, of course. And this concrete layer, approximately 300 long, is made continuous, so that at the ends there is no, end rotation effect that comes into play.
Okay. Next question is from Thomas Cornelay. He's asking what is the design axle load and what is its design life?
So design axle load is 17 tons, and design life is I think about 100 years.
Next, it's again from Shankar Dev. Did you have input sectional operating speeds in curves in advance to decide on a balanced applied cant?
So yeah, the alignment that was done for this project, we started off by getting the centerline alignment, then we broke that into up and down. So predominantly the alignment characteristics were defined by the client, and our intention was to maximize this speed in that particular section. And when we decided upon the applied cant, the cant efficiency, of course, we had taken a first iteration rule of 50% either way, and then try to optimize it further so that the overall speed in the project is as high as possible.
Yeah.
Mm,
So did you have the sectional? No, my question is, well, you tried as much as possible to theoretically balance the applied cant and cant efficiency, which is fine. That
Yeah.
is what a track
Yeah.
designer would do. My question is, did you have the ultimate sectional operating speeds by means of power supply and traction simulations beforehand?
No. So I understand where you're coming from. What we did was we allowed maximum permissible speed in that particular section, and then based on the rolling stock speed simulation, they could check in a particular curve if they are required to brake. But ideally, in order to design their equipments, to design their systems, the contract conditions were such that in all out mode they are supposed to run with maximum possible speed wherever it is possible. So that was the whole intention.
Okay, so basically it's for the rolling stock simulations, basically those mechanical simulations for wear and tear, you have considered the maximum possible, and probably
Yes.
you tried to balance wherever possible, like if it's near the stations or if there are curves adjacent to stations and stuff. Did you take was there any
So what we did
consideration?
was, of course, we did not directly interface this with the rolling stock, but we populated a curve list for each curve. What is the applied cant? What is the speed? We sent it to our employer, and then the employer was in discussion with the rolling stock. And then finally, when they approved it, they did some kind of fine tuning, And the background to that was they wanted to optimize everything everywhere, not provide the maximum cant that is possible in that particular section, but allow it with a reasonable cant so that the cant access can also be compensated pretty well.
That is what I wanted to know. Thank you.
Yeah.
Thank you.
Next question is from Sri Nagesh.
RSA
RSA analysis.
analysis
Yeah.
and its result.
Sorry?
Rail structure interaction analysis was done, and hopefully there was no requirement of any
We
SCG.
did do. So as I said in the beginning of the presentation, we were not supposed to do this project in an EPC mode. We were not the designers. There was a dedicated detailed design consultant for the project. Maybe they are aware of what was done on this.
I have another question. Sorry. These trains for the RRTS, they are manufactured by Alstom, right? And
Right.
they are. Do they have tilting, self-tilting mechanism, or they don't?
I'm not aware.
Oh, okay. Thanks.
And do you have any clearance issues with the structures? What is the minimum clearance you followed in this?
I think you will be
Vertical.
the right person to answer that, Ramuji, because you did this when you were with us.
No, I don't remember.
Yeah, we did. I mean, I must, congratulate Ramuji on this because when we were working together in the beginning of these kind of projects, we already established a certain set of automated sheets wherein we could do the SOD check. So SOD check basically means that wherever you have a structure cage, it should not infringe with any structure, maybe it a web of the girder or the tunnel lining or the ancillary utility services inside the tunnel. So those checks we did, and some of the cases we did find a clash. So for example, as I explained, in some cases you have this green color element lifting up on the tunnel lining. So we solved that by raising the rail levels slightly because we had that headway over here. And when we increase that level, you can imagine that at the rail section, this widens. If you increase the rail levels, you get a more width. And here also, if the rail levels is increased, this line also goes up slightly and you get more width over here. So those kind of iterations we had to do.
Yes. We have one more question from Nikhil Tyagi. Which software were used for LOD 500 BIM?
I think it was for the alignment, we did very basic with Civil 3D, and then finally we did that with Revit.
And I got one more question from Siva Akasapu. How precast slabs are managed in canted geometry? That arc raise thing, right?
No, arc rise is for curves. Canted geometry, you can see in this photograph, this is in a curve location. And this side, the in situ concrete is slightly thicker than on the inner side. So basically we manage this by the in situ stitching concrete, which tapers down and provides a super elevation.
Okay.
The precast slab, this is 160 millimeter thick consistently.
Siva, is your question answered?
Thank you. Yeah.
And I don't know, just to add on the arc rise, here you can see that there is a slight amount of arc rise in these slab elements. They are slightly curved. They are slightly curved like this. So this was also a part of the manufacturing process.
Yes. Okay, any more questions left?
I have one question. What is the headway, Akshay? Train headway minimum.
Headway, I need to check. I don't have that by heart right now, but I'll have to check in the operational plan.
Just curious, that's all.
So
But must be 3.5 minutes, I believe. I mean, at least if it is not there right now, but eventually maybe by 2030 or 2050, they're targeting at least this much.
So I'm happy that we finished the session with a lot of information, and I thank Akshay and LNT for sharing this amazing presentation with our attendees or audience. Thanks the audience. So thanks to Akshay. Thanks to LNT. And Sarah, you can stop the video.
Yeah, I think we have a staggering number of 77 members, Akshay. So this is, as you know, that PWI is a very niche area and it's very hard to find PWI professionals. Seeing so many
Right.
people joining this call is something very significant. No, it matters a lot for us as a PWI organization. So thank you again for the wonderful presentation. Thank you, Ramoji, for initiating all these things. And hope, Akshay, you will also join other presentations if you have time, so that we always have
Yes, of course.
knowledge sharing.
Yes, of course.
We would request, Mr. Akshay, we would request that you encourage more speakers in from L&T, because L&T is one of the largest infrastructure in railway, largest infrastructure companies working in India on massive projects. So please request, because what we want to do here in PWI is a free transfer of knowledge and knowledge sharing and the best practices, and we learn from everyone. You know, all the community learns from each other's experiences. We network, and you can also become a member, and you can also